Okay, I think it's about time for a math question, if that's okay with everybody else.
Please.
Here. What is the value of x when 2x plus 3 equals 3x minus 4?
Tell me that equation one more time.
2x plus 3 equals 3x minus 4.
Minus 4, okay. Cool, so we have to solve. So I'm going to guess this is a little bit more basic of an algebra equation. I say basic, it's not basic, don't get me wrong. But based on the question, I'm going to give a little bit more information just because so we can understand the fundamentals of solving algebra equations. I put the equation on the screen that the person asked about, and we're trying to solve for x. Anytime we're trying to solve for a variable, what our goal is that we need to isolate it. So goal is to isolate the variable. So isolate, meaning getting it by itself. So we need to keep that goal in mind. And if we keep that goal in mind, I guess really the rules are this. What we do to one side of an equation, we have to do to the other. So as long as you keep everything equal, that's kind of the golden rule of algebra, then we should be okay. And there are certain things we can do, certain strategies we can take, but as long as you do the same thing to both sides of the equation, you're all right. My rule of thumb, so if you're isolating the variable, one thing that I would like to do or think would make a lot of sense if you're isolating it is to get our variable all to one side of our equation. So you might notice in this equation we have variables on both sides. We have the 2x on the left and the 3x on the right. To isolate that wouldn't be easy because we have two of them. So we want to move them over to one side and then move all of our constants, and when I say constants, it's the numbers without the variables, move those to the other side so that our variable is by itself. So what I notice here, I've got 2x on this side, I have 3x on this side. It doesn't really matter which side of the equation you move them to. I tend to go to the one that there are more of them. So on the right side, I have 3x. On the left, I have 2x's. So I'm going to move them all to the right side since I already have more over there. So to move them, what I need to do is undo what they are, or do the opposite of what they are. We know that a number plus its opposite always gives us 0. So for example, if I did 2 plus negative 2, or in other words, a shorter way to do that would be 2 minus 2, we're always going to get 0. The same thing works for variables. If I did x plus negative x, so a number and its opposite, or x minus x, same thing, I'm going to get 0. And since our goal is to isolate the variable, we want to move it completely over to the other side. So I'm going to subtract 2x from the left side of the equation, and then I have to make sure I do it to the right side as well. On the left, those cancel. As I mentioned, they give us 0. And we're just left with 3 on the left side of the equation. On the right, we're doing our 3x minus 2x, because we're taking away that 2x. And we're left with just 1x, or just x, minus 4. And so we carry everything down. We want to make sure our equation stays equivalent. Every single step, it stays equivalent. Now you might notice that our variable over here, it just has this minus 4 with it. So same idea, we want to do opposite, do the inverse operation. So we're going to add 4 to both sides. And we end up getting 7 on the left and x on the right. So now that I've isolated the variable, I know what it is. I sometimes think about solving algebra equations kind of like opening a present, a gift or something. Like, imagine if you received a gift, you don't know what's on the inside because it's all wrapped up with all of these things kind of disguising it. And our only way of figuring out what it is to unwrap it and get it by itself. And then we can see what it is pretty clearly. And that's kind of the same idea with algebra equations, is we're trying to see what that variable is, and we can't really see it until we take out all the wrapping. All those other numbers around the variable is like the wrapping, for, I guess, a metaphor. I could also show us how to check it, but what we would do, I'll just kind of sum it up real quick, how to check it. We would replace our variable with the number we thought it was, 7, in our original equation, and we want to just make sure that it does make both sides equal. And it should in this case.